Welcome, everyone, to another episode of Science to Sleep By, where we let the wonders of the cosmos carry you into a state of calm curiosity. Tonight, we journey through the quiet corners of our solar system, visiting worlds that once captured the spotlight, but have since faded from common memory. These are the forgotten planets' celestial bodies that hold mysteries, beauty, and lessons about the history of our cosmic neighborhood. So, settle in, close your eyes if you wish, and let's drift together through space. When we look up into the night sky, we often think of the planets we know best: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These 8 worlds form the familiar cast of characters that make up our solar system. They are the names taught in schools, the orbits tracked in textbooks, and the worlds most often featured in stunning space images. But surrounding them, hidden in the shadows of astronomy's storytelling, exist other celestial bodies, worlds that were once considered planets, or once captured significant scientific attention, but have now drifted from the spotlight. These are what we might call the forgotten planets, the ones that sit quietly in the outer reaches, or in between classifications, waiting for curious minds to remember them. The idea of a forgotten planet is not about erasing their existence, but rather about how our culture, our science, and our language sometimes push certain worlds out of the conversation. When you hear the word planet, your mind likely goes to Saturn's rings or Mars's red dust, but rarely to Ceres, a world once hailed as a planet in the early 1800s. You may think of Jupiter's swirling storms, but forget about Haumea, an elongated icy body spinning so quickly it has a shape unlike anything else in our solar system. These worlds are not less real, not less fascinating. They are simply less remembered, tucked away in categories like dwarf planet, asteroid, or Kuiper belt object. The concept of a forgotten planet also raises an interesting point about human perspective. Planets are not forgotten by the universe they orbit. They evolve. They persist in their cosmic paths. They are only forgotten by us, by our limited focus. Astronomy is a science shaped by both discovery and story. When Ceres was first found, it was celebrated as a new planet between Mars and Jupiter. It had its moment in the spotlight, hailed as proof that the solar system held secrets beyond what we knew. But as more objects were found in its neighborhood, it was reclassified, first as an asteroid and later as a dwarf planet. Ceres did not change. It remained exactly what it was, quietly circling the sun as it always had. What changed was our definition, our framework, our storytelling. The forgotten planets invite us to consider how language and classification shape memory. Pluto's story is a perfect example. Discovered in 1930, Pluto was embraced as the 9th planet of the solar system, a cultural icon beloved for its distant, icy mystery. Generations of schoolchildren memorized its name alongside the others. Then, in 2006, the International Astronomical Union voted to redefine the word planet, and Pluto lost its official planetary status. Overnight, it shifted from being a household name as the 9th planet to being the most famous member of the dwarf planets. To scientists, Pluto's importance did not diminish. It remains a vital piece of the puzzle of how the outer solar system formed, but to the public, it became a sort of fallen star, a world both remembered and yet strangely forgotten. Lingering on the edges of our planetary imagination, the forgotten planets are also tied to the natural limits of human perception. When we look at Mars through a telescope, we see a world relatively close to Earth, a reddish disk with hints of surface detail. When we look at Jupiter or Saturn, we see giant spheres with distinct bands or rings, majestic and immediately captivating. But when we try to look at Ceres or Haumea or Makemake, we see distant specks of light. Their small size and immense distance make them less visually impressive. For centuries, much of astronomy relied on what we could see, and these faint, tiny objects simply did not capture the imagination the way the larger planets did. Even now, with spacecraft that can fly past them, they remain quiet worlds, known to specialists but absent from the broader cultural conversation. There is also the factor of narrative simplicity. Our solar system is vast, with countless objects orbiting the sun, from comets and asteroids to dwarf planets and moons. To make sense of it all, humans tend to simplify. We tell the story of 8 planets, perhaps mentioning Pluto, and stop there. The other worlds are not included, not because they are unworthy, but because they complicate the story. Yet within those complications lies a deeper beauty. The forgotten planets are reminders that the solar system is not a neat lineup of 8, but a dynamic, crowded, evolving space filled with diversity. Calling them forgotten also makes us reflect on how temporary our definitions might be. What we call a planet today could change tomorrow. In another century, perhaps Sedna, an object far beyond Pluto with a vast, elongated orbit, will gain recognition as something new, a category not yet named. Perhaps we will discover a world larger than Mars hidden in the distant reaches of the Kuiper Belt, reshaping our understanding once again. If that happens, today's forgotten worlds may return to prominence, remembered not as outliers but as trailblazers that prepared us for a broader view of what it means to be a planet. The forgotten planets also carry with them a sense of mystery that is both scientific and poetic. Unlike Earth, where we walk and breathe and experience life firsthand, these distant bodies are mostly known through data, images, and brief spacecraft encounters. They remain half-known, their surfaces only partially mapped, their histories only partly understood. That sense of incompleteness adds to their aura of being forgotten. They are not part of the daily planetary story, yet they hold untold secrets about how planets form, how they evolve, and what the edges of our solar system are really like. In a way, to speak of forgotten planets is to admit our own limitations. It is a reminder that the universe is too vast to hold entirely in human memory, that our attention drifts to the brightest, the biggest, the most immediate. But just as forgotten songs can be rediscovered, so too can these worlds be brought back into the narrative. When NASA's Dawn spacecraft visited Ceres, it revealed a world of icy mountains, mysterious bright spots, and possible subsurface oceans. Suddenly, Ceres was no longer just a footnote but a living subject of planetary science. When the New Horizons mission flew past Pluto in 2015, it revealed heart-shaped plains of nitrogen ice, towering mountains of water ice, and a landscape more dynamic than anyone expected. In that moment, Pluto was remembered, not just as a former planet, but as a complex, active world worthy of fascination. The concept of forgotten planets, then, is not static. It shifts with each discovery, each mission, reclassification. Worlds once forgotten can be remembered again, and worlds currently unknown may one day join them. The forgotten planets remind us that memory and attention are as much a part of science as observation and data, and that what we choose to highlight shapes our understanding of the cosmos. They ask us to slow down, to look again, to remember that the solar system is more than the 8 familiar names. It is a sprawling family of worlds, each with its own story, each deserving of its place in the grand narrative of space. For most of the 20th century, Pluto held a special place in the imagination of people everywhere. It was the little frozen world at the edge of the solar system, the 9th planet in every classroom chart and every astronomy book. Discovered in 1930 by Clyde Tombaugh at the Lowell Observatory, Pluto was a triumph of both prediction and patience. Astronomers had suspected that a mysterious Planet X might exist beyond Neptune, and when Pluto was finally spotted, it was celebrated as the answer to that search. Though much smaller than expected, it was embraced as the 9th planet, rounding out the solar system in a way that felt complete. For decades, children memorized its name along with Mercury through Neptune, and the sequence of 9 planets seemed set in stone. Yet, as science advanced and our understanding of the solar system grew, Pluto's status began to waver, and eventually, it was reclassified as a dwarf planet, a decision that continues to spark debate, nostalgia, and reflection. Pluto's story begins with discovery, but its early identity was built on assumptions. When Tombaugh located it, Pluto appeared as a faint moving dot against the backdrop of stars. Its mass and size were not immediately known, and astronomers at first believed it to be much larger than it really was. estimates placed Pluto at nearly the size of Earth, which seemed to justify its planetary status. Over time, as observations improved, its true smallness became apparent. Pluto is less than 1/5 the size of Earth, and even smaller than Earth's moon. Instead of being the massive outer planet astronomers had envisioned, it turned out to be a tiny, icy body far less imposing than the giants Neptune and Uranus that orbit nearby. But cultural momentum is powerful. By the time scientists realized how small Pluto was, it had already been cemented in textbooks, maps, and minds as the ninth planet. Its location also added to its aura of mystery. Pluto occupies a region of the solar system known as the Kuiper Belt, a vast collection of icy objects orbiting beyond Neptune. For much of the 20th century, Pluto was seen as unique, a solitary wanderer in this distant frontier. But as telescopes improved in the late 20th century, astronomers began to find more and more Pluto-like objects in the Kuiper Belt. By the early 2000s, it became clear that Pluto was not alone, but rather the largest member of a family of icy bodies that populate the outer reaches of the solar system. This discovery forced scientists to confront a difficult question. If Pluto is a planet, should these other similar objects also be called planets? The tipping point came in 2005 with the discovery of Eris, a Kuiper Belt object that was initially thought to be larger than Pluto. If Pluto were to remain a planet, then Eris, too, would need to be classified as one. But if Eris were called a planet, then what about the many other bodies in that region? Should the solar system suddenly contain dozens, or even hundreds, of planets? To prevent this, the International Astronomical Union (IO) stepped in to establish a more precise definition of the word planet. In 2006, the IO ruled that a planet must meet 3 criteria. It must orbit the Sun, it must be spherical due to its own gravity, and it must have cleared its orbital neighborhood of other objects. Pluto met the first 2 requirements, but it failed the third. Its orbit is populated with other icy bodies in the Kuiper Belt, and it does not dominate its region in the way that, for example, Jupiter does. By this new definition, Pluto was no longer a planet, but instead a dwarf planet. The decision sparked immediate controversy. For many people, Pluto's demotion felt personal. It was not just a scientific reclassification, but an emotional one. Pluto had been part of our collective imagination for decades, a symbol of the distant unknown, the little planet that held its place proudly among the giants. To remove it from the list felt, to some, erasing a piece of childhood. Public campaigns emerged demanding that Pluto be reinstated as a planet, and debates played out not only in scientific circles, but also in popular culture, late-night comedy, and even politics. Some states in the US passed symbolic resolutions declaring Pluto to remain a planet, reflecting the deep affection people held for this tiny world. From a scientific perspective, however, Pluto's reclassification opened the door to a richer understanding of the solar system. By acknowledging Pluto as a dwarf planet, astronomers could also embrace Ceres, Eris, Haumea, and Makemake under the same category. Instead of diminishing Pluto, it placed it at the head of a fascinating new class of celestial bodies. Pluto became a representative of the diversity of the outer solar system, a key to understanding the Kuiper Belt and beyond. It became less of an oddball and more of a trailblazer, showing us that the solar system is more complex and varied than we once imagined. Pluto's own features also defy the idea of insignificance. In 2015, NASA's New Horizons spacecraft flew past Pluto, giving humanity its first close-up view of this distant world. What it revealed stunned scientists and the public alike. Far from being a frozen, inert rock, Pluto was alive with geological activity. Its surface displayed towering mountains of water ice, smooth plains of frozen nitrogen, and evidence of glaciers slowly creeping across the landscape. The most famous feature, a heart-shaped region now called Tombo Regio, became an emblem of Pluto's enduring charm. Beneath its surface, scientists suspect that Pluto may even harbor a subsurface ocean, kept liquid by internal heat. Its thin atmosphere, composed primarily of nitrogen with traces of methane, rises and falls as it interacts with the sun's energy, creating a dynamic and ever-changing environment. Pluto, once thought to be a simple frozen rock, turned out to be one of the most complex and active worlds in the solar system. The demotion of Pluto also reveals how science evolves. What we teach, what we call things, even what we consider important, shifts as knowledge grows. When Pluto was discovered, astronomers had only a partial picture of the solar system. Pluto fit the framework of the time, even if imperfectly. As new discoveries poured in Eris, the Kuiper belt, the understanding of orbital dominance, the framework had to be updated. Pluto's story illustrates that science is not static. It is a conversation between evidence and interpretation, always open to revision. What remains constant is Pluto itself, orbiting on its elongated path around the Sun every 248 years, unchanged by the labels we give it. Despite its change in status, Pluto has not been forgotten. If anything, its demotion has made it more famous than ever. Once just the 9th name on a list, Pluto is now the subject of books, documentaries, and debates. Its story resonates because it mirrors something human: the struggle between belonging and being cast aside, the tension between tradition and change, the bittersweet reality that definitions evolve. Pluto is both remembered and forgotten, both diminished and elevated. It may not be a planet in the official sense, but it remains, for many. The planet of the heart. To call Pluto a forgotten planet is to highlight how easily attention shifts to the big and the dominant while the small and the fragile drift into the margins. Yet, in another sense, Pluto is unforgettable. Its demotion did not erase it from the skies, and its reimagining as a dwarf planet has given it new importance as a window into the history of the solar system. Its heart-shaped plain, its icy mountains, its mysterious interior, all of these remind us that even the smallest worlds can be vast in their complexity, and that being reclassified does not mean being diminished, but being understood in a deeper, truer way. Long before Pluto's rise and fall in the planetary lineup, another world experienced a similar fate: Ceres. Its story is older, stretching back to the dawn of the 19th century, when astronomy was still taking shape as a modern science. At that time, the solar system was a place of wonder, but also of gaps. Between the orbits of Mars and Jupiter, astronomers noticed a missing region, a space where, according to the mathematical pattern known as the Titius-Bode law, a planet ought to exist. This puzzle fascinated scientists of the era. They believed that somewhere in that wide space, a hidden planet was waiting to be discovered. The search began in earnest, and what was found in 1801 would become a tale of discovery, celebration, reclassification, and eventual reawakening. That object was Ceres. Ceres was discovered on the very first night of the new century by Giuseppe Piazzi, an Italian astronomer. At first, he thought he had found a star, but its slow drift across the sky revealed it to be something else, a body orbiting the sun. This was a moment of triumph. Here was the missing planet, the long-sought world that seemed to fill the gap between Mars and Jupiter. Ceres was welcomed with excitement, catalogued as the 8th planet, and given a name that linked it to ancient mythology. Named after the Roman goddess of agriculture and fertility, Ceres represented life and nourishment, a symbolic choice for a planet thought to complete the solar system's family. For a time, Ceres stood proudly in the planetary ranks, but its reign was short-lived. Not long after its discovery, astronomers began to find more objects in the same region. Pallas was found in 1802, Juno in 1804, Vesta in 1807, and eventually hundreds more. The once empty space between Mars and Jupiter turned out to be a crowded neighborhood filled with small rocky bodies. The dream of a single hidden planet gave way to the reality of a swarm of objects, what we now know as the asteroid belt. By the mid-1800s, Ceres and its companions were no longer referred to as planets, but as asteroids. Ceres, the first of its kind to be found, lost its special status and faded into the background of astronomical attention. For over a century, Ceres was remembered mostly as an asteroid, albeit the largest one. Its planetary moment was over, and the giants of the solar system, Jupiter, Saturn, Uranus, Neptune, dominated the stage. Yet Ceres never ceased to be remarkable. At nearly 600 miles across, it is by far the biggest object in the asteroid belt, accounting for about a third of the belt's total mass. Unlike most asteroids, which are irregularly shaped, Ceres is rounded by its own gravity, giving it the appearance of a true world. Still, classification and perception matter, and for much of modern astronomy's history, Ceres was left out of the planetary narrative. Everything began to change in the late 20th and early 21st centuries as scientists developed a more nuanced understanding of what makes a planet. When Pluto was reclassified in 2006, the International Astronomical Union introduced the term dwarf planet to describe bodies that are spherical and orbit the Sun, but have not cleared their orbital neighborhoods. Alongside Pluto, Eris, Haumea, and Makemake, Ceres was reintroduced to the world not as a planet, not as an asteroid, but as a dwarf planet. After more than 150 years in obscurity, Ceres returned to planetary status, albeit in a new, humbler category. This reawakening of Ceres's identity coincided with a new era of exploration. For centuries, it had been seen only as a faint point of light in telescopes. Then, in 2007, NASA launched the Dawn spacecraft, a mission designed to visit two of the largest objects in the asteroid belt, Vesta and Ceres. After exploring Vesta, Dawn entered orbit around Ceres in 2015, making it the first spacecraft ever to orbit a dwarf planet. What Dawn revealed transformed our understanding of this forgotten world. Ceres is far from being a dull rock. Its surface is diverse, shaped by geological processes that suggest a dynamic history. One of the most striking discoveries was the presence of bright white spots inside its craters, most famously in the Occator crater. At first, these spots baffled scientists, sparking speculation about alien cities or icy outposts. In reality, they turned out to be deposits of sodium carbonate, a type of salt left behind when briny water seeped to the surface and evaporated. These bright spots are like cosmic fingerprints, evidence of subsurface water reservoirs and geochemical activity. They show that Ceres is not just a static relic, but a world where processes continue to shape the surface. The idea that Ceres may hold subsurface water has made it a world of immense scientific interest. Beneath its icy crust, scientists suspect there could be a vast layer of briny liquid, perhaps even a subsurface ocean. While not the kind of ocean that would be comfortable for humans, such environments are thought to be potential habitats for microbial life. In this way, Ceres joins other icy worlds like Europa and Enceladus as candidates in the search for life beyond Earth. For a world once relegated to the category of asteroid, this possibility elevates its importance tremendously. Ceres also offers a unique perspective on planetary formation. It appears to be a transitional object, sharing features of both rocky planets and icy moons. Its composition suggests that it formed early in the solar system's history, preserving materials that can give us clues about the conditions in the protoplanetary disk. Unlike the larger planets that underwent dramatic changes, Ceres remains small and relatively stable, acting as a time capsule of the early solar system. Studying it is like reading the pages of a very old book, one that records events from a time long before Earth was fully formed. In addition to its science, Ceres holds cultural and symbolic resonance. As the goddess of agriculture, Ceres represented nourishment, fertility, and growth. Fittingly, this little world, forgotten and then rediscovered, now offers nourishment of a different kind: knowledge. It reminds us that discovery is not just about the biggest or brightest objects, but also about the ones that linger quietly, waiting to reveal their secrets when the time is right. The story of Ceres reflects the ebb and flow of human curiosity, how we can celebrate, forget, and then rediscover the value of something that never stopped being remarkable. Ceres's demotion from planet to asteroid, and its eventual recognition as a dwarf planet, mirrors the story of Pluto, but on a quieter scale. Both worlds highlight the evolving nature of science, the way definitions and categories shift with new knowledge. Both also demonstrate the tension between human simplicity, we like neat lists of planets, and the universe's complexity, which resists being boxed into tidy categories. Ceres challenges us to broaden our view, to accept that the solar system is not just a lineup of 8 planets, but a vast landscape filled with worlds of every size and type. In recent years, Ceres has continued to capture attention not only for its scientific mysteries, but also for its potential future role in exploration. Because of its water-rich composition, it has been suggested as a potential outpost for future human missions. Water can be used not only for drinking, but also broken down into hydrogen and oxygen for rocket fuel. In this way, Ceres could become a stepping stone for journeys deeper into the solar system. Imagine a future where spacecraft stop at Ceres to refuel on their way to Jupiter or Saturn. This little world, once forgotten, might one day become a gateway to the outer planets. Ceres, the planet that was and then wasn't, embodies the fluid nature of knowledge and memory. It shows how definitions can change, how worlds can be celebrated, ignored, and then celebrated again. It reminds us that the solar system is not static but alive, filled with stories still unfolding, with mysteries waiting for us to pay attention. In the silence of space, Ceres has always been there, orbiting faithfully between Mars and Jupiter, whether we called it a planet, an asteroid, or a dwarf planet. Its existence does not depend on our categories, but our understanding of it deepens as we shift our gaze back toward it. Remembering what was once forgotten and realizing that even the smallest worlds can hold immense significance in the distant reaches of our solar system. Far beyond the orbit of Neptune lies a world that few had ever heard of until it ignited one of the most passionate debates in modern astronomy. This world is Eris, a dwarf planet that was discovered in 2005, and whose very existence forced scientists to confront a fundamental question: what exactly is a planet? The story of Eris is not just about discovery, but about the power of definitions, the weight of tradition, and the willingness of science to change course when confronted with new evidence. Eris became the catalyst for redefining what it means to be a planet, and in doing so, it forever changed the way we see our solar system. The discovery of Eris was made by astronomer Mike Brown and his team at the Palomar Observatory in California. Using advanced telescopes and digital imaging, they spotted a faint, slow-moving object in the outer solar system. At first, it appeared to be just another icy body, one of many scattered across the region known as the Kuiper Belt. But further measurements revealed something startling. Eris was about the same size as Pluto, perhaps even larger. This was not just another small object, but a world on the scale of the 9th planet itself. For decades, Pluto had been considered an outlier, a lone icy planet orbiting at the edge of the solar system. But the discovery of Eris shattered that perception. If Pluto was a planet, then surely Eris must be as well. The implications were enormous. If Eris were declared a planet, then the Kuiper Belt, with its thousands of icy bodies, might contain dozens more worlds that qualified for planetary status. The tidy list of 9 planets, memorized by generations of students, would suddenly expand into a sprawling catalog of dozens or even hundreds. The solar system, once simple and orderly, would become far more complex. For many astronomers, this was a thrilling possibility, a reminder that science is always evolving. But for others, it was an unwelcome complication, a threat to the clarity of the planetary framework that had stood for centuries. The discovery of Eris set off a debate that raged for months and eventually came to a head in 2006 at a meeting of the International Astronomical Union (IO). Astronomers gathered to decide once and for all how to define the word planet. Until that point, the term had been used loosely, more a matter of tradition than strict scientific criteria. Mercury through Neptune were clearly planets. Pluto had been added in 1930 and accepted despite its small size and unusual orbit. But with Eris in the mix, the ambiguity could no longer be ignored. The IO proposed a definition that required a planet to orbit the Sun, to be spherical under its own gravity, and to have cleared its orbital neighborhood of other objects. By that standard, Eris, like Pluto, did not qualify. Both worlds shared their orbits with other bodies in the Kuiper belt, meaning they had not cleared their paths. The verdict was controversial. Pluto and Eris were reclassified as dwarf planets. For many, this decision was heartbreaking. Pluto, long cherished as the ninth planet, was demoted. Eris, despite its size and significance, was denied entry into the planetary family. The decision sparked headlines around the world, and for the first time in decades, the public was deeply engaged with the scientific debate about planetary science. Some accused the EO of taking away Pluto's planetary status unfairly. Others argued that the definition of a planet was arbitrary and too restrictive. The controversy continues even now, with some scientists proposing alternative definitions that would restore Pluto and Eris to planetary rank. Yet, no matter which side one takes, there is no denying that Eris was the spark that forced this debate into the open. Beyond the controversy, Eris itself is a fascinating world. It is located in a region known as the scattered disk, a part of the outer solar system populated by icy objects with highly elongated and tilted orbits. Eris's orbit takes it far beyond Pluto, at times nearly 3 times farther from the Sun than Pluto at its most distant. A single orbit of Eris takes 557 Earth years, meaning that since its discovery, it has barely moved along its vast path. Eris is accompanied by a small moon named Haumea, discovered shortly after Eris itself. The presence of a moon allows astronomers to calculate Eris's mass more precisely, confirming that it is slightly smaller than Pluto in diameter, but more massive overall. This makes Eris the most massive known dwarf planet in the solar system. The surface of Eris is thought to be covered in frozen methane, giving it a reflective, icy appearance. Observations suggest that it is one of the brightest objects in the outer solar system, reflecting most of the sunlight that strikes it. In the cold outer reaches where sunlight is faint, Eris exists in a realm of near-permanent winter, a frozen world locked in silence. Its surface temperature is estimated to hover around -400 degrees Fahrenheit, making it one of the coldest known places in the solar system. Despite its remoteness, Eris has become a symbol of how much remains undiscovered in the outer solar system and how our understanding is still incomplete. Eris also challenges our perspective on what it means to matter in science. Though it was denied the label of planet, Eris forced astronomers to look more carefully at the solar system's architecture. It revealed that Pluto was not unique, but one of many similar bodies in a vast population. It helped confirm that the Kuiper belt and scattered disk are not just regions filled with debris, but regions filled with worlds small, distant, but significant. By questioning Pluto's status, Eris also expanded our concept of planetary diversity. If the solar system contains icy dwarfs like Eris and Pluto, rocky asteroids like Vesta, gas giants like Jupiter, and ice giants like Neptune, then the word planet may never be enough to capture the full richness of these worlds. In the years since its discovery, Eris has maintained a quieter presence compared to Pluto, which continues to dominate public imagination. Part of this is because Pluto has been visited by a spacecraft, New Horizons, which revealed it in stunning detail. Eris, by contrast, has never been visited directly, and our knowledge of it remains limited to observations from telescopes. Yet Eris continues to intrigue scientists. Its sheer mass and distant orbit make it an important test case for theories of how the solar system formed and evolved. Studying Eris may help us understand how icy worlds were scattered outward during the early years of planetary formation, shaped by the gravitational influences of the giant planets. Eris's story also reflects the human side of science. Discoveries are not just about data, they are about meaning. Eris could have quietly joined the catalog of icy worlds without much fanfare, but because it rivaled Pluto, it became central to a debate about identity and classification. Its discovery forced us to reconsider long-held traditions and confront the idea that the universe does not conform to our tidy categories. Science had to adapt, and in adapting, it revealed its strength, the ability to change in the face of new evidence. Eris reminds us that definitions are tools, not truths, and that sometimes a single discovery can reshape an entire field of knowledge. To call Eris a forgotten planet is to recognize the irony of its place in history. It is forgotten in the sense that it never received the cultural embrace of Pluto, never earned a place in the rhymes and mnemonics used by schoolchildren. Yet, it is unforgettable in its impact. Without Eris, Pluto might still be considered the ninth planet, and the solar system might still be described as a neat lineup of 9 worlds. Instead, thanks to Eris, we now see the solar system as more complex, more diverse, and more dynamic than ever before. Eris may orbit in darkness, but it has illuminated the way we think about planets and challenged us to embrace the richness of a universe that does not always fit into the categories we prefer. Among the distant icy bodies that orbit beyond Neptune, 2 worlds stand out not only for their size, but for their unique and puzzling characteristics. These are Haumea and Makemake, both recognized as dwarf planets, and both belonging to the same family of forgotten planets that seldom make it into popular discussions about the solar system. Their names may not be as familiar as Pluto, and they have never held the cultural spotlight in the same way, yet their stories reveal just how diverse and unexpected the outer solar system truly is. Together, they embody the sense of wonder that comes with discovering worlds so far away, and so different from anything we know closer to home. Haumea was discovered in 2004, though its discovery quickly became a matter of controversy. 2 teams of astronomers claim to have found it, one in Spain and one in the United States, and disputes over who deserved the credit became entangled in professional rivalries. Despite the debates about its discovery, Haumea's existence was beyond doubt. What made it fascinating from the beginning was not just its location in the Kuiper belt, but its strange physical appearance. Unlike most large celestial bodies, which are roughly spherical due to their own gravity, Haumea is elongated, stretched into an almost egg-like shape. This is because it rotates at an astonishing speed, completing one full spin on its axis every 4 hours. That rapid rotation causes it to bulge at the equator and flatten at the poles, giving it a distorted form unlike any other large object in the solar system. Haumea's odd shape is not its only distinguishing feature. It also has a pair of small moons, named Hiaka and Namaka after figures from Hawaiian mythology, fitting since Haumea itself is named after a Hawaiian goddess of fertility and childbirth. The presence of these moons suggests that Haumea may have experienced a violent collision in its past, an event that could explain not only its unusual shape, but also the family of smaller objects that appear to share its orbital characteristics. These objects are thought to be fragments from Haumea's outer layers, blasted away in a long-ago impact. If true, Haumea is more than just a world, it is the heart of a larger family, a kind of mini-system formed by cosmic violence. Another remarkable feature of Haumea is its surface composition. Observations show that it is covered largely in crystalline water ice, making it one of the brightest objects in the Kuiper belt. This brightness, combined with its fast rotation and odd shape, makes it unlike any other dwarf planet. Beneath that icy exterior, scientists suspect there may be a rocky core, and possibly even a thin layer of liquid water, kept warm by residual heat from radioactive decay. The possibility of liquid beneath the surface places Haumea in the growing list of icy worlds that may once have harbored, or could still harbor, conditions favorable to life at a microscopic scale. It demonstrates that the Kuiper belt is not just a region of dead, frozen rocks, but a place of geological complexity and dynamism. If Haumea is a world defined by its strangeness and speed, Makemake offers a different kind of mystery. Discovered in 2005, around the same time as Eris, Makemake was one of the discoveries that forced astronomers to reconsider the definition of a planet. Like Pluto and Haumea, it resides in the Kuiper belt, orbiting the Sun at a great distance, with a period of about 310 years. Slightly smaller than Pluto, it is still large enough to be spherical, and thus earned recognition as one of the dwarf planets. Its name comes from the deity of creation in the mythology of Rapa Nui, the indigenous people of Easter Island. connecting this distant icy world to the traditions of one of Earth's most isolated cultures. Makemake's surface is thought to be covered with methane ice, along with nitrogen and possibly ethane, giving it a reddish-brown hue. Its brightness makes it one of the easiest Kuiper belt objects to observe with telescopes, but its remoteness still makes it a challenging target for detailed study. Unlike Pluto, Makemake has not yet been visited by a spacecraft, so much of what we know comes from careful observations with powerful telescopes on Earth and in orbit. For a long time, Makemake was thought to be moonless, unlike many of the other dwarf planets. Then, in 2016, astronomers discovered a small, faint moon orbiting it, provisionally nicknamed Mek-2. This discovery not only added to Makemake's intrigue, but also gave scientists a way to better measure its mass and density, critical clues to understanding its composition. What makes Makemake particularly interesting is its atmosphere, or rather, its lack of one. While Pluto has a thin but detectable atmosphere that expands and contracts as it moves closer to or farther from the Sun, Makemake appears to have almost none. The methane on its surface suggests it could once have had an atmosphere, but its weak gravity and great distance from the Sun likely caused it to lose most of it into space. This difference between Pluto and Makemake, despite their similarities in size and composition, offers important lessons about how small worlds evolve. The comparison highlights how slight differences in distance, temperature, or gravity can result in vastly different outcomes in planetary development. Together, Haumea and Makemake paint a picture of diversity in the outer solar system. Haumea spins so fast that it defies the normal rules of planetary shape, while Makemake shines brightly with methane ice, but clings to little or no atmosphere. Both are distant, cold, and rarely mentioned outside of astronomy circles, yet both expand our understanding of what kinds of worlds can exist. They are reminders that the solar system is not a tidy system of 8 planets, but a sprawling collection of unique and often bizarre bodies, each with its own story. The neglect of Haumea and Makemake in popular culture says more about us than about them. Because they are small, distant, and hard to see, they do not easily capture the public imagination in the way Saturn's rings or Jupiter's great red spot do. Yet, when examined closely, they are every bit as fascinating. Haumea shows us a world shaped by speed and violence, while Makemake shows us the delicate balance between atmosphere and emptiness. Both worlds teach us that the boundaries of planetary science are not fixed, but open, and that discovery is an ongoing process. One of the most profound lessons from these dwarf planets is the realization that the solar system is still full of surprises. Even in the 21st century, we are finding new worlds large enough to reshape our definitions and challenge our assumptions. Haumea and Makemake were unknown just a generation ago, and yet now they stand as permanent members of the planetary family, recognized as dwarf planets alongside Pluto and Eris. Their discovery proves that exploration is far from over, and that the solar system is not fully mapped but still filled with mysteries waiting to be uncovered. The scientific importance of Haumea and Makemake also extends beyond our solar system. As astronomers search for exoplanet orbiting distant stars, they find many worlds that do not fit neatly into familiar categories. Some are gas giants orbiting extremely close to their stars, while others are rocky planets larger than Earth, but smaller than Neptune, a type we do not have in our own system. By studying the diversity of dwarf planets like Haumea and Makemake, we gain insights into the kinds of planetary processes that might shape worlds elsewhere in the galaxy. These icy dwarfs remind us that planets come in many forms, and that what seems unusual here may be common elsewhere. In the end, Haumea and Makemake are not just strange names in an astronomical catalog. They are worlds with distinct identities, shaped by forces of collision, rotation, composition, and distance. They may be overlooked in the grand story of the solar system, but to forget them is to miss a crucial part of the narrative. They are evidence that the universe does not conform to simplicity, that beauty and wonder often lie in the places we pay the least attention to, and that even the quietest, most distant worlds have voices worth listening to, beyond the familiar planets and the more widely recognized dwarf planets like Pluto. Haumea, Makemake, and Eris, lies a vast region filled with countless icy bodies that orbit in the farthest reaches of our solar system. This region, known as the Kuiper Belt, and extending even farther into the scattered disk and the inner Oort cloud, is a place where sunlight is faint, where temperatures plunge to extremes, and where the worlds that exist remain largely invisible to the naked eye. It is here in this distant and mysterious frontier that astronomers have uncovered other dwarf planets and planet-like bodies, objects that are rarely spoken of outside the scientific community, yet offer some of the deepest insights into the origins and structure of the solar system. These are the hidden worlds beyond Neptune, and they are as fascinating as they are forgotten. One of the most intriguing among them is Sedna. Discovered in 2003, Sedna's orbit is unlike that of any other known body in the solar system. While Pluto and most Kuiper Belt objects follow paths that keep them relatively close to the Sun compared to the scale of the solar system, Sedna ventures into the deep dark, with an orbital period estimated at more than 11,000 years. At its farthest, Sedna travels nearly 1,000 times farther from the Sun than Earth does. Its extreme orbit raises questions that scientists still struggle to answer. Some believe Sedna may have been influenced by the gravity of a passing star billions of years ago, while others suggest it could be evidence of a massive, undiscovered planet lurking in the outer solar system, often referred to as Planet 9. Sedna's reddish surface, likely caused by Tholin's organic molecules created by radiation interacting with simple compounds, makes it one of the more visually unique objects in the solar system. It stands as a sentinel at the edge of what we know, a world that bridges the gap between the Kuiper Belt and the theoretical vastness of the Oort cloud. Another fascinating body is Orcus. Sometimes described as the anti-Pluto, Orcus shares a similar orbital resonance with Neptune as Pluto does, meaning its path around the Sun is stabilized by Neptune's gravity. Yet unlike Pluto, Orcus travels on the opposite side of the solar system, making it a kind of mirror twin. Orcus is accompanied by a moon, Vanth, which is unusually large compared to Orcus itself. This pairing suggests a complex history, perhaps involving collisions or capture, and studying it helps astronomers understand how moons can form around small bodies. Orcus is thought to contain a mixture of rock and ice, and like other dwarf planets, it may conceal secrets about the conditions present in the early solar system. Quaoar is another overlooked world orbiting in the Kuiper Belt. Discovered in 2002, it is roughly half the size of Pluto and possesses a surface that hints at water ice and possibly cryovolcanic activity, volcanic eruptions not of molten rock, but of water, ammonia, or methane. If cryovolcanism is confirmed, it would mean that even small, distant worlds can be geologically active, challenging the assumption that heat and dynamism are reserved only for larger planets or moons. Quaoar's orbit is more circular than that of some of the other distant dwarfs, which makes it an interesting case study for understanding orbital evolution. Alongside Quaoar orbits its moon Waywatt, a small companion that, like Vanth around Orcus, provides a valuable tool for measuring the system's mass and density. Farther out, there are other bodies such as Gonggong. Discovered in 2007, Gonggong is a reddish world with a diameter of about 1,200 kilometers, accompanied by a small moon named Shangliu. Its reddish coloration, similar to that of Sedna, is thought to be the result of complex organic materials on its surface. Gonggong's orbit is tilted at an unusual angle compared to the other planets, suggesting that it may have been influenced by gravitational interactions in the early history of the solar system. Worlds like Gonggong remind us that the architecture of the solar system is not neat and symmetrical, but filled with orbits that are eccentric, inclined, and irregular, reflecting a chaotic past of collisions and near encounters. Another name in the catalog of distant worlds is 2007 or 10, an object even larger than Haumea, though it has yet to be officially named as a dwarf planet by the International Astronomical Union. Its size alone makes it one of the largest known bodies in the outer solar system beyond Pluto, and it too has a moon. Preliminary studies suggest its surface contains water, ice, and methane, and its reddish tint links it again to the organic chemistry that seems to permeate these remote regions. The discovery of such large bodies, even in the last 2 decades, underscores how incomplete our map of the solar system truly is. These distant worlds, while small compared to the giants like Jupiter or Neptune, are crucial to our understanding of planetary science. They are relics from the early days of the solar system, frozen time capsules preserving materials that have not changed significantly in billions of years. Studying them allows scientists to peer back into history, to see what conditions were like when the planets were forming. Because they are so far from the sun, their surfaces and compositions have been altered less by heat and radiation, making them pristine archives of cosmic history. The diversity of these dwarf planets also broadens our understanding of what a planet can be. Sedna, with its extreme orbit, challenges the neat boundaries of the solar system. Orcus, with its large moon, reveals the dynamics of binary systems. Quaoar, with potential cryovolcanism, suggests that even small worlds can harbor internal activity. Gonggong, with its tilted orbit and reddish surface, shows the variety of conditions in the outer reaches. Each of these worlds is a piece of the puzzle, and together, they demonstrate that the solar system is not a finished story, but a living laboratory of exploration. What makes these worlds particularly compelling is that they remind us of how much remains unseen. The Kuiper belt and scattered disk likely contain hundreds or even thousands of objects large enough to be considered dwarf planets, yet only a handful have been studied in detail. Most are too faint or distant for current telescopes to observe clearly, and only spacecraft venturing into these regions could truly reveal their nature. The success of the New Horizons mission to Pluto in 2015 showed what is possible when we visit one of these distant bodies directly. In just a short flyby, humanity's view of Pluto transformed from a blurry point of light into a detailed world of mountains, plains, and hazy skies. Imagine what similar missions could reveal about Sedna, Orcus, or Quaoar, entire landscapes, climates, and histories that today remain nothing more than guesses based on limited data. The exploration of these outer worlds is also tied to some of the biggest questions in astronomy. The unusual orbits of Sedna and other distant objects may hint at the existence of Planet 9, a massive, unseen planet that could be shaping the structure of the outer solar system. If Planet 9 exists, it would fundamentally change our understanding of the solar system's architecture, and the study of smaller distant bodies is the path to either confirming or disproving this hypothesis. In this way, even the tiniest of these forgotten worlds hold the keys to unlocking mysteries far larger than themselves. Even though these dwarf planets and distant objects are overlooked in popular imagination, they represent a frontier as rich and mysterious as any in astronomy. They extend the solar system far beyond the orbit of Neptune, reminding us that the 8 classical planets are only the beginning of the story. The Kuiper belt and beyond are not empty, but teeming with strange, icy, and ancient bodies that continue to reshape how we think about planets, evolution, and the structure of our cosmic neighborhood. When people speak about the solar system, the conversation almost always revolves around the 8 major planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. They are the worlds that fill the pages of textbooks, the ones taught in classrooms, and the ones that feature in countless documentaries and space illustrations. Yet orbiting alongside them, scattered across the asteroid belt, drifting in the Kuiper belt, and wandering along faraway elliptical paths, are other worlds that also hold the title of planet in one form or another: dwarf planets, minor planets, and distant planetary candidates. These worlds, including Pluto, Ceres, Haumea, Makemake, Eris, Sedna, and many more, rarely appear in mainstream discussions. They are often overlooked, neglected, or even dismissed. To understand why these planets became forgotten, it is necessary to look not only at science, but at history, culture, visibility, and the way humans frame their understanding of the cosmos. The first reason lies in how we define a planet. For centuries, The term planet was applied loosely to any object that moved across the sky relative to the fixed background of stars. This included not only Mercury, Venus, and Mars, but also the Sun and Moon. As telescopes improved and more objects were discovered, the definition of a planet began to shift. The discovery of Uranus in 1781 added a new major planet to the solar system, followed by the discovery of Neptune in 1846. In 1801, Ceres was also discovered between Mars and Jupiter and was initially considered a planet. But soon, astronomers realized that Ceres was only one of many similar bodies occupying the same region, leading to the creation of a new category, asteroids. Ceres was demoted, and with that, the concept of forgotten planets began to take shape. The same process repeated itself in the 20th and 21st centuries with Pluto. Discovered in 1930, Pluto was welcomed as the 9th planet and held that title for 76 years. Generations of schoolchildren memorized its name, and its icy remoteness sparked imagination. But in the early 2000s, discoveries of similar-sized objects like Eris challenged its status. In 2006, the International Astronomical Union voted to reclassify Pluto as a dwarf planet, grouping it with Eris, Haumea, Makemake, and Ceres. This change reduced the official number of planets from 9 to 8, and cemented the forgotten status of these smaller worlds. The decision was scientific. It was meant to create a consistent definition, but it also carried cultural consequences. By narrowing the category of planet, many objects were pushed into obscurity. Another reason these worlds were forgotten is simple visibility. The 8 major planets are relatively bright and easy to observe even with modest telescopes, and some can be seen with the naked eye. Jupiter and Saturn, with their size and beauty, dominate the night sky. Mars, with its reddish glow, captures the imagination. Even Venus, often called the morning star, shines brightly. By contrast, the dwarf planets and distant minor planets are faint and far away. They require advanced telescopes and careful observations to detect. For most of human history, they were invisible, and even now they remain hidden to all but astronomers. In a culture where visibility and immediacy shape memory, these faint objects naturally fade from common awareness. Cultural storytelling also plays a major role in why certain planets are remembered while others are forgotten. Throughout history, the planets visible to the naked eye were tied to mythology, astrology, and human tradition. Venus was associated with love, Mars with war, Jupiter with kingship, and Saturn with time. These associations gave the planets lasting significance in culture. The dwarf planets, discovered only in recent centuries, lack such cultural weight. Their names drawn from various mythologies remain unfamiliar to most people, and without deep cultural roots, they do not command the same resonance in human memory. Another factor is educational focus. In classrooms, children are often taught simplified models of the solar system. The 8 planets are listed, sometimes accompanied by a mnemonic phrase to help remember their order. Rarely are students introduced to the complexity of the Kuiper belt, the Oort cloud, or the multitude of dwarf planets that orbit the Sun. This simplification is practical. Education thrives on clarity, but it leaves out entire categories of worlds. Once excluded from early education, these forgotten planets rarely enter the minds of the general public. Later in life, media coverage and public fascination also shape what is remembered. When spacecraft visit planets, those planets capture global attention. Mars has rovers roaming its surface, Jupiter has had the Galileo mission, and the Juno orbiter, Saturn had Cassini, and even Mercury has been visited. Images from these missions have filled magazines, news headlines, and online feeds. Meanwhile, most of the dwarf planets have never been visited by spacecraft. Only Pluto, through the New Horizons mission in 2015, has been seen up close. The stunning images of mountains, ice plains, and hazy skies briefly brought Pluto back into cultural focus. But other dwarf planets like Haumea, Makemake, and Eris remain represented only by artists' impressions. Without images or missions to inspire awe, they linger in obscurity, scientific priorities have also contributed to their neglect. Resources for space exploration are limited, and agencies tend to prioritize missions that promise the most return in terms of knowledge, technological development, or potential human exploration. The major planets, particularly Mars, have been the focus of intense study because of their proximity and potential for habitability. By contrast, dwarf planets and distant objects are seen as less practical for exploration, requiring far longer missions and greater resources. As a result, they occupy the periphery of scientific planning, waiting for future generations of explorers. Another dimension is human psychology and the desire for order. People often prefer categories that are simple and manageable. 8 planets are easy to memorize, easy to draw in diagrams, easy to arrange in models. The inclusion of dozens, even hundreds, of dwarf planets complicates this picture. To keep the narrative simple, the forgotten planets are left out. This streamlining, while useful for communication, comes at the cost of accuracy and completeness. Yet, these forgotten worlds are not insignificant. In fact, they are central to understanding how the solar system formed and evolved. The Kuiper Belt objects are thought to be remnants from the earliest days of planetary formation, frozen in time and preserving information about the conditions of the early solar system. Dwarf planets like Ceres reveal the processes that occurred in the asteroid belt, while Sedna's distant orbit hints at forces beyond the known planets. Their scientific value is immense, but their cultural presence is minimal. This gap between importance and recognition explains why they are remembered by astronomers, but forgotten by most people. In the end, the forgotten status of these planets is not due to a lack of wonder or significance, but rather a combination of visibility, definition, culture, education, and priorities. They do not shine brightly in the sky. They do not appear in myths told for thousands of years. They are not easily accessible for exploration, and they do not fit neatly into simple lists. They are the quiet members of the solar system, overshadowed by the giants and ignored in popular memory. Yet they remain there, orbiting silently in the cold reaches of space, waiting for the rare moments when human curiosity turns toward them again. When we speak about the forgotten planets Pluto, Ceres, Haumea, Makemake, Eris, Sedna, and so many other distant or reclassified worlds, we are not just talking about icy rocks drifting in the cold void. We are talking about fragments of a cosmic story, pages torn from the earliest chapters of the solar system's book. To remember them is to recognize that the solar system is not merely a clean, simplified model of 8 shining spheres orbiting the sun, but a vast, messy, an endlessly fascinating family of worlds that together shape our understanding of where we came from and where we might be going. The value of remembering them lies not only in the science they hold, but also in the imagination they inspire, the perspective they provide, and the humility they demand of us as explorers of the universe. On a scientific level, forgotten planets are like time capsules. The major planets Earth, Jupiter, Saturn, and the rest have undergone billions of years of change. Their surfaces, atmospheres, and internal structures have evolved, erasing many traces of their early histories. But the smaller, colder bodies beyond Neptune and in the asteroid belt have remained largely preserved. Their icy shells and rocky interiors hold the chemical fingerprints of the materials that existed when the Sun and planets first formed 4.5 billion years ago. By studying them, scientists can glimpse the building blocks of the solar system in their original state. A core of water ice here, a trace of methane there, or a hint of complex organic compounds scattered across a surface. Each of these is a clue, like an ancient fossil revealing how life and planets once began. Remembering these planets also broadens our view of what planetary diversity truly means. If we only think of planets as massive, spherical, and visually impressive, like Jupiter or Saturn, we miss the quieter but equally astonishing forms that planets can take. Haumea, spinning so rapidly that it is stretched into an elongated shape, defies the expectation that planets must be round. Makemake, coated in methane ice yet devoid of an atmosphere, shows how fragile and fleeting atmospheres can be. Ceres, once classified as a planet, later dismissed as an asteroid, and now reborn as a dwarf planet, demonstrates how our categories shift as knowledge deepens. Each of these examples challenges rigid definitions and reminds us that nature rarely conforms to neat labels. In remembering them, we keep alive the lesson that science is not about fitting the universe into our terms, but about expanding our terms to fit the universe. The forgotten planets also play an essential role in the larger architecture of the solar system. In the search for life beyond Earth, these forgotten planets may also hold significance. While giant planets and rocky Earth-like worlds often dominate the headlines in exoplanet research, the icy dwarf planets in our own solar system could harbor subsurface oceans or complex organic chemistry. Haumea, with its water ice, or Ceres, with its potential briny reservoirs, suggests that even small worlds may provide habitats for microbial life. Remembering them keeps open the possibility that life in the universe is not confined to Earth-like planets, but could arise in the most unexpected places. Ultimately, the value of remembering forgotten planets is about curiosity itself. Human progress has always depended on looking beyond what is obvious, on refusing to stop at what is familiar. The forgotten planets invite us to continue asking questions, to push deeper into the solar system, and to keep alive the wonder that drives exploration. They may not be the brightest, the largest, or the most glamorous, but they carry within them secrets that can reshape our understanding of the universe. By remembering them, we affirm that every world matters, that every orbit has a story, and that no corner of the cosmos is too small or too distant to deserve our attention. As we drift back from the far reaches of the solar system, past Pluto's icy heart, beyond Haumea's stretched form, across Makemake's frozen surface, past Eris, Sedna, and the countless hidden worlds that quietly orbit in the darkness, we are reminded of something profound. The solar system is not simply a collection of 8 familiar planets circling the sun in a neat arrangement. It is a sprawling cosmic family, filled with forgotten worlds, overlooked bodies, and mysteries that challenge our definitions of what a planet even is. These forgotten planets, whether they were once demoted from planetary status, discovered too late to find a place in popular imagination, or simply too faint to be seen with the naked eye, hold immense scientific and philosophical value. They are time capsules from the dawn of the solar system, guardians of its earliest secrets, and examples of nature's boundless creativity. To remember them is to acknowledge that wonder does not belong only to the giants and the bright worlds, but also to the quiet and the distant dot. In telling their stories, we restore them to the narrative of our cosmic neighborhood. We expand the boundaries of what it means to be a planet, and we remind ourselves that exploration is far from over. The forgotten planets may not dominate the night sky, but they shape the history of the solar system just as surely as Earth, or Jupiter, or Saturn. They remind us that discovery is not about the most obvious, but about the willingness to look deeper, to wonder about what lies beyond, and to listen to the whispers of worlds that orbit in the silence of space.